In this video, we are going to be using the technique of factoring to solve some equations. First, here are the general steps that we're going to follow to solve these equations. The first step is always to try and combine as many terms as you can and set your equation equal to 0. Once you have it set equal to 0 and put everything together that you can, it's going to be time to try and factor. Once you have it factored, you're going to set each factor equal to 0. So you're going to be creating new smaller equations and then solving each of those equations. Let's take a look at example 1. In this example, there's not a lot of things I could put together, but I do need to move some things around in step 1 so that it is equal to 0. The fastest way to set this equal to 0 would be to take this 28 and move it over here. And that's totally fine. However, I'm going to suggest that maybe we should take these two terms and bring them over here. Remember, in order to factor, we want that lead coefficient to be positive. And right now, my lead coefficient is a -2. And if my lead coefficient is -2, that means I'm going to have to do a little extra work in order to factor it. And that's fine. It just means your GCF would have to be negative to fix that before you start factoring the rest of it. But I think in order to avoid that problem, I'm just going to move everybody to the other side, and that'll make him positive. So I'm going to move this 2x squared to the other side. So I'm going to add 2x squared to both sides. I'm also going to move this 18 over, so I'm going to add 18x to both sides. And we're going to see what we got here. So over here on the left, these guys are all going to cancel out and leave me with nothing, so 0. On the other side, there's no like terms, so I think I'm just going to put them in the correct polite order here. So 2x squared, I've got 18x, and I've got a 28 for a constant with no x. Remember, if they're not like terms, you can't put them together. Now I'm going to start factoring. Step 2, let's get it factored. I noticed there is a GCF though. There's a 2 that we could pull out. So let's pull that 2 out and see what we've got left in here. This is actually good news. Do you see this? It's just an x squared. There's no number in front of it, which means we don't have to use that AC method. This is one that's going to factor pretty nicely. Now you could use AC, but it's kind of a bunch of waste of time that we don't have to do it on this one. But if it makes you feel better, you can do it. Remember, when it starts with x squared, we know it's x times x. I'm still going to come out here to the side to look for these factors, though. I've got a positive 14. Plus tells me same signs. This right here, plus 9, that tells me these are both positive. So I'm looking for things that multiply to 14. So that'd be like 1 and 14, and 2 and 7, and that's it. And to get that 9, I'm going to use the 2 and the 7. Since they're both positive, it doesn't matter which one goes where. And we're just going to bring these back over here. Now we've got it all factored. Okay, next step. Set each factor equal to 0. Now, there's lots of ways to tackle this too. Technically, you could just divide everything by 2, and this GCF of 2 would disappear. But for practical purposes, I'm going to just stick to the plan, set each of the factors equal to 0. So 2 equals 0. Is that true? No, that's just silly. He's not going to count. But x plus 2 could equal 0, and x plus 7 could equal 0. And then we're going to solve each of these for x. So get x by itself. I got -2. And get x by itself over here. And I get -7. Both of those are answers to this equation. Meaning I could put -2 back in here for x and simplify this, and it would give me 28. I could also put -7 in here for x and simplify this, and it would also give me 28. But those are the only two numbers that would work. Let's try number 2. First things first, it's not simplified and set equal to 0. Since most of my stuff is over here and this x squared is positive, I think it's probably the best thing would be to move everybody over to this side. So this negative 5x has got to come over. So let's move him. He's negative 5x, so I would add 5x, and I think I'll just put him over here with his like term. So what we'd have left would be 4x squared, and then we could put these guys together to give me 8x, and then plus 3. So step 1 is done. We've combined all the things we can combine, and it's set equal to 0. The next thing we need to do is factor. Now, unfortunately, there's no GCF, and I have a number in front of my x squared. Anytime there's a number in front of your x squared, the technique we've been using is AC method. So I'm going to take the A, 4, times the C, 3, and write it over here. It's positive 12. Plus in the back tells me same signs. I look in the middle, it's a positive 8. So I know over here these are both positive. Looking for things that multiply to 12. So 1 and 12, 2 and 6, 3 and 4, and I think that's it. I'm looking for an 8 in the middle. There's my 8. And since they're both positive, it doesn't matter where you put them. We're good to go. So back over here, I'm going to take that 8x and break him up into plus 2x and plus 6x. That's still 8x. Then we can use our grouping technique. So pulling a 2x out of the first group would leave me with 2x plus 1. Pulling a positive 3, out of the second group would leave me with 2x plus 1. And so my GCFs would be 2x plus 3, and my matchy guys are 2x plus 1. And now we've got it factored. So step 2, get it factored. Took us a while, but we got there. Next, we are going to set each of those factors equal to 0. So 2x plus 3 is equal to 0, and 2x plus 1 is equal to 0. And then we need to solve each of these equations. So I'm going to minus the 3 over, and then divide by my 2. Don't panic here. When you divide by 2, you're just going to have negative 3 over 2, or negative 3 halves. Over here, I'm going to minus my 1, and then divide by my 2. Again, don't panic. It's just negative 1 over 2, or negative 1 half. Okay, last one. Let's see. We got a lot going on here. There's a whole bunch of stuff over here and a whole bunch of stuff over here. So we're going to have to do some moving around. Since this is my biggest exponent and he's positive, I think I'm going to leave this here and bring everybody over here to him. So I've got to move this 6x to the other side. So minus the 6x. I'll put him with his friend over here. I'm going to minus the 2, put him with his friend over here. So these guys are going to cancel out, and I'm going to have just a 0 over there, which is good news. On the left side, I've got x to the third. For my x's, negative 10 and negative 6 would be negative 16 of them. Oh, whoa, that's kind of cool. These guys are canceling out. All right. And equal to 0. So I've combined all my like terms, and I've set it equal to 0. The next thing we're supposed to do is try and factor this. I see a GCF. I'm going to pull an X out. Always GCF if you can. And then I'm still trying to factor this. And you notice that inside the parentheses now, I have 2 terms. Anytime it's 2 terms, we're thinking it's one of those special cases. This is a difference of squares. Now, if you need to, you can come over here to the side and decide what A and B are to get this factored. What when you square it is x squared? Well, that's x. And what when you square it is 16? That's going to be 4. So the factored version, don't lose your GCF, is going to be a minus b, so x minus 4, and a plus b, x plus 4. Once we have it factored, we're going to set each of our pieces or each of our factors equal to 0. Now, interesting thing. We saw a GCF earlier that was like a 2 and it didn't give us any answers. But if your GCF has a variable like ours does, he is going to give us an answer. So I'm going to set the first factor, which is x, equal to 0. The second factor, x minus 4, equal to 0. And the third factor, x plus 4, equals 0. So here's an actual answer, x equals 0. Then to get this one, I need to add the 4 over. So there's a second answer. And then here I'm going to minus the 4 over. And here's my third answer. Now, not always, but a lot of times when you start with a cubic thing in your equation, that's a good hint that you might possibly end up with 3 answers, and that's very common. So that's kind of a thing to kind of look out for. If you have a cubic power, it's likely, not always, but likely that you're going to end up with 3 answers for these. But remember, if this GCF has a variable, he has an answer. If the GCF does not have a variable, he's not going to give you an answer.